This presentation is delivered by the Stanford Center for Professional Development.
All right, C++ plus Java versus Java. It's like a death match. Okay, what's the same? The first thing I really do want to talk about is that there are a lot of things that are the same. And so you are building on a background that's going to serve you well without having to make a lot of adjustments. In some sense, they're almost so similar at times to be a little bit unhelpful in the sense that it's easy to get tripped up because they almost but not quite are exactly the same. There was one unfortunate quarter where I was teaching two classes, one that was being taught in C++ and one that was in Java, and I was just a mess the whole quarter, like constantly in one class using the wrong syntax and vice versa. Luckily, I'm not doing that now, so hopefully I'll have my C++ head on straight the whole quarter. The general syntax, so I'm going to mention these things and I'm going to show you a sample program and we're going to walk through it. But the things like the comment sequence, the slash star, the slash slash, right? The use of almost all the punctuation characters, braces, parens, commas, semicolons, is exactly the same, right? That the statement terminator that the semicolon is used for, the commas to separate arguments going into a function call, the way you make variable and parameter declarations, right? Exactly the same, right? No changes there to be aware of. All of the primitive variable types, char, int, double, plus the kind of more esoteric long and float and short and things like that are present in Java are present in C++ and have basically the same semantics. There is one minor adjustment there, which is Java's Boolean type, the true-false variable type, is actually called bool in C++. So you have to type a few less characters on that end. All of the operators that manipulate the basic types, the assignment operator is the equal sign, the equals to compare, not equals to see if they're not equal, the arithmetic plus, the plus equal, multiply equal shorthands, the plus that comes in both pre and post increment, the relational less than or equal to. The logical operators and, or, and not have the same behaviors. They have the same short circuiting, the same precedence table. So all of that, right, is without change. The control structures, so for redirecting control flow and making choices about what code to execute when, the for and while loop mechanisms, the if with the optional else, the switch statement, which you may or may not have seen, but you can definitely look up in the text if you haven't, right, that kind of has like a variant of the if-else that lets you decide based on the value of something which case to move into. The return that's used for the function. Also things like the break and continue, little less known keywords there, or the do while also. Same thing that they operate in Java, they work the same way in C++. So hopefully you feel a little bit like, okay, I'm not totally in a foreign land. Let's look at a complete C++ program. So this one is printed in handout 4. If you want to follow along there, make notes on it as we talk it through. And what I'm going to do here is I'm actually planning on just kind of walking through this almost line by line to kind of just point out some of the things that are different. And then I'm going to move to the compiler and we'll do a little bit of experimentation with developing and writing some code and manipulating something that looks like this to just kind of get some of our bearings about what things are going on. Okay, so first off, just some general structure, right? A C++ program is traditionally written in a text file with the suffix somename.cpp for C++. There's actually some other names that sometimes get used like .cc or .C that are also accepted by a lot of compilers. So some text extension, though, that identifies that this file has C++ code, there's a couple variations. We'll use CPP. The program is traditionally, in a simple form, is just one file, just that one CPP file with all of the code that's necessary to be in there. So let's take a look at it. This one starts with a comment, always a good idea, right? Using the /* multi-line comment to identify it. It says, oh, this is average.cpp, and it adds scores and prints their average, right? So just like all the good style habits that you have in Java, hopefully translate quite well to C++ about just explaining to the reader where we're going and what we're doing. The next 3 lines are pound include statements. Pound include is analogous to the Java import. So the C++ compiler is pretty rigid about wanting to see things kind of in the proper order. Before you start using some facility, it wants to know about it. That's really part of kind of the safety of making sure you're using it correctly. So if you plan on drawing something to the screen and doing some graphics, it wants to be sure you're making calls to the graphics functions correctly with the right arguments, the right names, the right arrangements. And so in order to know that, it has to ahead of time have seen that that bit of structure and interface. And so the way this is done in C++ is through these interface or include files. And the pound include mechanism is really fairly primitive. It basically says, look for exactly a file with the name genlib.h and take its contents and kind of dump them right here. The contents of genlib.h and simpio.h are actually, to give you just a little insight, we're going to see them more later, list the operations and the facilities that are available in this particular header that we're trying to include. In this case, the genlib is a 106 specific header that all our programs will include. It gets us set up with some basic foundations. The simpio is our simplified I/O header that adds some features for interacting with the user at the console. The next one down there, right, is include IOStream. IOStream is a C++ standard header. And that helps to point out the difference between why in one place I was using double quotes to name the header file I'm looking for. In one place I'm using angle brackets. That this is a way that's distinguished for what header files are what are called system standard. And it looks for them in a particular place where the standard header files are. Those are always enclosed in the angle brackets. And then in double quotes are local headers that are specific to this project or this environment, right, that are not C++ standard. So whenever you see these double quotes, you'll think it's my own local headers or headers from the cs106 libraries. Anything in angle brackets is a system standard header you'd find everywhere. So it kind of matches like what you do in import, right? You say, I'm going to be using these features from this class. Let me import its features into here so that the compiler knows about them. Next little line I got here is a declaration of a constant. This is the const whose name is numScores. And so it looks a little bit like a variable declaration, right? From this point over, right, you see I have int numScores equals 4, semicolon. Looks a lot like a variable declaration. The const in the front of it is our way of telling the compiler that this particular value, right, once assigned will not change. So it is equivalent to kind of the use of final in the Java language in many ways. To say that. And so this is being declared kind of outside of context. So maybe one point to make here, right, is that C++, right, it derives on more than one way of expressing code and what we call its paradigm. So Java is a completely object-oriented language. Every line of code you wrote went inside a class. It's all about classes. You wrote this class that manipulated the thermometer. You wrote this class that, you know, drew with the turtle or whatever. But there was no code that ever existed outside of a class. It always was. You started off with public class something and you started writing methods that operated on that class. Maybe they were static or maybe not. And that the way you started code was always to say, start from this class's main to get work done. C++, right, is a hybrid language. It has object-oriented features. It has the ability to define and use classes, and we'll see that quite extensively. But it also inherits the legacy of C, which is pre this whole object-oriented development, where it operates more procedurally, they call it, in the procedural or imperative paradigm, where there are functions that exist at the global level that don't have a context of a class that they operate in. There's not some this that's being received the message and operating. They're just functions that exist outside this, like a little set of things to do that don't live inside a class. And for much of the term, we're going to be doing stuff in a very procedural way, at least in the code we write, and we will use a lot of objects. So we'll actually be mixing and matching a little bit of those paradigms together. So using the procedural paradigm to write a lot of code that then happens to manipulate objects using an object-oriented set of features. So in this case, right, the program here, this is just actually up at the top level, and it's saying this is a global constant that's available anywhere in the file after this declaration. I can use the numScores, which will refer back to this without any further adornment. The next thing underneath that is a prototype. So this is actually a little bit of a novelty that in Java you are allowed to declare, if you have three methods, A, B, and C, and maybe A calls B and B calls C, you can declare A, B, and C in any order that's convenient for you. You want to put them alphabetically, you want to put them in the order they're called, you want to put them in the order that the kind of top to bottom down or bottom up. It doesn't matter, because the Java compiler kind of looks at everything once and then kind of goes back to get the whole picture. C++ tends to want to look at a file once, kind of top to bottom, and not have any reason to go back and revisit things. It happens that in the main function, which is the one where code starts from, I want to make a call to this getScores and average function. And if I had left this prototype off and I had this code here, when it gets to this line where I'm making that call, the compiler hasn't yet seen anything about get scores and average. It's actually on the next page. And it will complain. It will say, I don't know what this function is. You haven't told me about it. It came out of nowhere. And this prototype is our way of informing the compiler about something that's coming up later. And so the prototype tells about the return type, the name of the function, the type and names of the arguments and the order of them, and then ends with a semicolon. And it's just it matches exactly the function header that we'll see on the next page. And it just tells the compiler in advance, here's something that's coming up later in the file, is a function with this name and this signature. So something you didn't have to do in Java, but is a part of the C++ world. There's actually an alternate way I could have done this, which is when I show you the code for get scores and average, if I actually just define them in the other order, I could avoid that separate prototype. And it's a little bit of a matter of personal taste, which way you feel comfortable doing it. So let's look at this guy. So main is special. The actual name, lowercase M-A-N-E, M-A-I-N, whatever. I'm a terrible speller, by the way. Has no arguments, returns an integer type. This is the function in a C++ program where execution starts. There can be exactly one main function with this name and this signature, and it will, when the program kind of gets up and running, the first thing it does is start executing the lines of code that come in this function. So no objects are created or any kind of fancy outer structure the way it might be in Java. It just really just goes here and just starts doing what you told it to do. So main has a special role to play in any program. What this program does is first print something. And this is the C++ syntax for printing things out. Even if you haven't ever seen it, you probably can get a little bit of an idea of what it's trying to do if you just kind of step back from it and squint a little. It looks a little bit like system.out.println. This is what's called the console out, the standard out here that's on the left-hand side. And then these use of the double less than here is what's called the stream insertion operator. So the standard output stream is saying insert into that stream, and then in the double quotes is a string. This program averages. And then it says insert next to that the num scores, which is this constant. It got the value from above, and then another string. And then at the very end, there's this little end L, which is the end line insertion, what's called a stream manipulator. It says at the end of this, put a new line and start any subsequent text on the next line. So in Java, right, that would look like a system.out.println of this program averages plus the num scores plus that using the string concatenation and conversion stuff in Java. It looks a little bit different in C++, but in the end result, right, it's a matter of printing out a bunch of things, numbers and strings intermingled, new lines, nothing too fancy there. Okay. The next line is make an call to that function that we've earlier told it about, we haven't yet seen the code for, that makes a call to get scores and average. It passes the constant num scores and says that's how many scores. It turns out that parameter is used to decide how many iterations to run the loop, requesting values, and then it returns the average of the values entered. And then we take that number, so we stored it in a variable. So this just shows that in C++, right, you can declare variables anywhere, either at the start of a block, in the middle of a block, kind of where they are at, and just like you can in Java. And then we took that value, stored it in this variable, and then used it in the next print statement. And then finally, last thing we have is a return 0. The signature for main in C++ always returns an integer. That integer is not all that useful in most situations. It's intended to be a kind of a return that tells the operating system who invoked the program whether everything completed successfully or not. By default, the value that's used to show successful completion is 0. So unless you have some other reason, it is return 0 that you'll always see at the end there. In reality, if you return something else, you won't see a lot of other differences. You turn -1 or 642. In most contexts, that number is almost ignored. So. But it is there just to kind of make tidy. All right, I'm about to flip to the next part. And this is the decomposed function, right, that main made a call out to, that does the averaging of the scores. Got a little comment on the top, right, that tells a little bit about how it works. Always a good idea to kind of get some documentation in there that's helping the reader get oriented. That same matching of the prototype